Good day everyone! Welcome to Modern Physics channel. On this video, we will talk about spatial relativity. This is Leo Sinalio from BSED Science 3A. Spatial relativity is an explanation of how speed affects mass, time, and space. This theory includes a way for the speed of light to define the relationship between the space and time. Let's start with time dilation. Time dilation tells us the faster we move relative to the speed of light, the slower the time will pass for us. In this theory of spatial relativity, the slowing down of clock as determined by an observer who is relative in motion with respect to the clock. Let's say Robinson's family is in the ship called Jupiter 2, moving at 80% light speed. If they move at this constant speed for what they measure as 2 years, how long will that be for Dr. Smith who left behind on Earth? By using the formula of time dilation, we have the delta t, or the dilated time interval that is framed in motion with respect to the event, is equal to delta to, or the proper time interval, which is the frame at rest with respect to the event, divided by the square root of 1 minus v squared. V is the velocity of the ship, or the Jupiter 2, divided by the c squared, or the speed of light. First, we're going to identify the given values. We have the proper time interval of 2 years, the velocity of the ship or the Jupiter 2, which is 0.80 c, and we're going to find the dilated time interval. Next is substitute all the given values. 0.80 c times 0.80 c is equal to 0.64 c squared. Cancel both same units, which is c squared. 1 minus 0.64 is equal to 0.36. The square root of 0.36 is equal to 0.6. Therefore, 2 years divided by 0.6 is equal to 3.33 years. Therefore, if the Jupiter 2, where Robinson's family on board, will moves at 80% light speed for 2 years, Dr. Smith, who left behind on Earth, will measure 3.33 years.
Use the engine from the alien ship to build the Resolute, a massive spaceship capable of reaching Alpha Centauri.
The Resolute traveling to Alpha Centauri at 97% light speed takes 4 years to get there as measured on Earth. Dr. Smith is now on board. How long the voyage does it seem to her? In order to calculate the proper time interval that is framed at rest with respect to the event, we are going to use the formula of time dilation. First, we're going to identify the given values. We have the dilated time interval, which is framed on motion with respect to the event, is equal to 4 years, and the velocity of the Resolute of 0.97 c, and the proper time interval is unknown. And now, substitute all the given values. We have the dilated time interval of 4 years is equal to the proper time interval divided by the square root of 1 minus 0.97 c squared divided by c squared. Now, square the velocity. 97 c squared is equal to 0.9409 c squared. Cancel both same units, which is c squared. 1 minus 0.9409 is equal to 0.0591. Therefore, the square root of 0.0591 is equal to 0.2431. Now, let's cross multiply. 4 years multiplied by 0.2431 is equal to proper time interval multiplied by 1. 4 years times 0.2431 is equal to 0.97 years, or approximately 11 months and 19 days. Therefore, Dr. Smith will measure the voyage of the Resolute as 0.97 years or 11 months and 19 days bound to Alpha Centauri.